Computer Programming Essentials, Unit 7, Part 1. You may recall that we learned there are three basic control structures in procedural programming and structured programming that allow us to solve virtually any problem that can be solved with a computer. And they are sequence, selection, and iteration. In this unit, we're going to learn about the third structure, iteration. We will learn about the loop structure, creating while loops, using shortcut arithmetic operators, creating for loops, creating do-while loops, nested loops, and how to improve loop performance. So, the loop structure allows you to repeat a block of statements over and over and over. The loop body is the block of statements that will be executed repeatedly, and one execution of a loop is called an iteration. There are three types of loops in Java: the while loop that controls a loop while a certain Boolean expression is true, the for loop that performs a specific number of loops. It is a count-controlled loop that loops a specific number of times, and the do-while loop, that's a post-test loop. It iterates and then tests a loop control condition to see whether or not it should continue looping. Here's what that might look like. In the for loop, in the flowchart, some Boolean expression. If it's true, the loop continues. Otherwise, it continues on with the program. A while loop executes a body of statements continually as long as a Boolean expression that controls the loop continues to be true. We call that the loop control condition. It consists of the keyword while, followed by a Boolean expression within parentheses that represents the loop control condition, followed by the body of loop, which can be a single statement or a block of statements surrounded in curly braces. A while loop is good for a definite loop, and a definite loop is also called a count-controlled loop, and it performs a task a specific number of times. This slide says it's also called a counted loop. I prefer to call it a count-controlled loop, and I apologize, I should have made that change. To write a definite loop, you need to initialize a loop control variable. That's the variable whose contents determines whether or not the loop continues, and that is the variable that forms the loop control condition. And then while that loop control variable does not pass a limiting value, that's the statement that would cause the loop to end, it continues to execute. There are three basic parts to every loop: initialize, test, and update or increment. The initialization is where you create the loop control condition or the loop control variable, as we talked about on the previous slide. The test is the Boolean condition that controls whether or not the loop continues. And the update is where we modify that loop control condition inside the loop to make sure that it stands a chance of reaching the end of the loop control condition. Here's what this might look like. The initialization would be val equals 1. We initialize the loop control variable. The test is in the diamond. Val less than limit, test. Should we continue looping or not? If that condition is true, we update val. We're updating the loop control condition. We output val, and then we say val equals val plus 1. That's our update, where we modify the loop control condition. And then test again. We don't initialize again, but we test again and update again. Test, update, test, update, test, update. And what that looks like in code is int val, final int limit equals 11, val equals 1, while val is less than limit, output val, and update val. Val equals val plus 1. The body of the while loop must include a statement that alters the loop control variable, as in our example, val equals val plus 1, because otherwise we will have a loop control condition that never ends. We'll have a loop that never ends. The loop control condition will always be true unless we update the value of the loop control condition inside the loop, and we don't want to write an infinite loop. Nobody writes an infinite loop on purpose, but everybody who's trying at one point or another will write an infinite loop. So we have a song about that. We'll sing in class. So, 4 greater than 2. If 4 is greater than 2, we're going to loop. Is that an infinite loop? You betcha, because 4 will always be greater than 2. So that represents an infinite loop. You can suspect an infinite loop when the same value is output repeatedly, or the screen remains idle for a period of time. And to break out of an infinite loop, we can hold down the control key and press C or break. You can also hit the stop run button in the IDE. It just looks like a red square to stop the running of your program. Here's another example. Loop count equals 1 while loop count is less than 3. System.out.println hello, loop count equals loop count plus 1. So we've initialized loop count, we've tested loop count, and we've updated loop count. And take a look at what that looks like in a flow chart. We initialize loop count equals 1. We test loop count less than 3. If it's true, we output hello, and we update loop count equals loop count plus 1.